we're taking the derivative of 3y equals 2x squared plus cosine of y. And with those, the way the x's and y's are distributed, this is going to be difficult to solve for y, which is when we say, okay, well, we're going to use implicit differentiation, which means we're thinking of y as an implicit function of x. So this 3y, when I do its derivative, I have to apply the chain rule because y is a function of x, and that means I need to multiply by the derivative of the inside being y in this case. So 3y is 3 times the derivative of y, which I'm going to call y prime. I don't have to worry about that when I do a derivative of the next term. Those function like normal because we're taking the derivative with respect to x. So this is just a power rule. Bring the power down in front, decrease the power by 1, and that part's done. And now the derivative of cosine y. Derivative of cosine is negative sine. We leave the inside alone, so that stays as y, times the derivative of the inside. The inside is the y here. And we just said derivative of y is y prime. So now we see that we have two y prime terms and one without a y prime. And we want to solve for y prime. So what I'm going to do is I'm going to add this term. It's sine of y times y prime. I'm going to add that to both sides because what that does is it gets both terms with y prime in it on the same side, cancels it out from here. So I have 3y prime plus sine of y prime equals 4x to the first. We don't need to write the 1. But here's the advantage of doing this. Now I can factor out the y prime on the left-hand side. 3 plus sine of y equals 4x. And I will divide both sides by 3 plus sine of y. That gives me my y prime. 4x over 3 plus sine of y.